Recall that we can have compounds that are structurally identical but spatially different. We have here two butenes, but2-ene, that are unable to flip back and forth between each other. This double bond locks the molecule in that orientation. And so I have but2-ene and but2-ene that are different. I need a way to differentiate those. And traditionally, we've used the cis and trans notation. Now, this is so common that we will need to know it, but it is not the official IUPAC naming convention. So cis and trans are Latin terms, cis meaning the same side, trans meaning the other side. So we see that my methyl groups here, this is CH3 and CH3, are on the same side of my but2-ene. And so this would be the cis version of that molecule. So I can call this cis but2-ene. This, I can see that my two methyl groups are on the other side of that double bond. And so it becomes trans but2-ene. Now this seems kind of finicky. Like, why is this? This is so specific. Why does it matter? Well, it does actually make a difference. And one of the main differences that is common across all cis and trans diastereomers is going to be a difference in melting and boiling point. So cis but2-ene has a boiling point of 4 degrees. So this one, boiling point, 4 degrees. Trans but2-ene has a boiling point of 1 degree. This is a very subtle difference. The reason for this is that methyl groups, these methyl groups here, draw electrons very weakly. And so they actually have a slight positive charge. So if I look at this, I have a slight polarity here, just enough to give me a difference. And so on one side of this molecule, I'm more negative. On the other side, I'm more positive. On this one, I kind of balance out. And so these molecules are more attracted to each other, resulting in them wanting to stay together at higher temperatures. A slight difference, but it does make a difference in some applications. Now, that's my boiling point. My melting point, that is going to be different. The melting point of cis but2-ene, I don't have the exact melting point here. However, because of trans ability to more neatly stack on top of itself, I mean, if I draw a second one here, this is very easily able to stack a bunch of versions of itself. None of them will rotate, where this, that's less likely to stack on top of itself. And so, in a solid configuration, trans is more stable. And so while it has a lower boiling point, it has a higher melting point. And cis has a lower melting point. Now, if my boiling point is 4 degrees, my melting point is going to be below 0. So why is this relevant? I mean, at 0 degrees, these are liquids, both of these. Well, this comes into play in a very specific situation for us, especially given our modern food intake. I'm sure you've heard of saturated and unsaturated fats. Saturated fats are simply carbon chains that have no double or triple bonds, and so every carbon is fully saturated with hydrogens. An unsaturated fat would be something that has somewhere a double or triple bond, and so these 4 carbons are not fully saturated with hydrogen. That's what saturated versus unsaturated fat means. And it really comes into play on how much energy can this molecule provide. However, my cis and trans fats, there's a subtle difference here. Remember, these cis molecules have a lower melting point, and so they're more likely to be a liquid. Trans fats would have a higher melting point. They'll be more likely to be a solid, especially at the temperature of our body. And so if I have cis fats and I eat the cis fats, they're going to be a liquid. They're going to move through my body quite easily. Trans fats, on the other hand, if I eat those are able to stay as a solid. Those can clump up in my own body. So just that small difference in melting point actually turns trans fats into a cause of heart failure. That's a pretty significant impact. So here I've got two more molecules. We should be able to identify which one is cis and which one is trans, just using that terminology. Cis is the two substituents are coming off of the double bond on the same side. Trans is they're coming off on the other side. So it's the difference between coming off this way, coming off this way. So I've got these two are coming off on the same side. Therefore, this must be cis. Now I could go through and count my carbons. 1, 2, 3, 4, 5, 6, 7. This is going to be cis, hept, 2, ene. There we go. This one, my carbon chains are on the other side of each other. So this is trans. And 1, 2, 3, 4, 5, 6, 7. Hep, 2, ene. There we go.